All right, so it seems I can. Give me a second. I just wanna make sure we're. Let's just edit this. Let's say today we're gonna be doing something different. Let's say setting up K3S Raspberry Pi cluster. So that's what we're gonna be working on a bit. All right, nice. And then what was I doing before? I would get this chat, right? Yeah. And then I would put this chat inside of my OBS, right? Yeah, I remember that. Custom browser docs. Yeah, so if there's anybody on YouTube, I can also read the chat. Yeah, sign into chat. I think we're almost there, and then we catch up, my friends. Nice. Okay, cool. Great. I think I have it there now. Alrighty, fellas. Let me switch to full screen. So what is up, everybody? It's been 3 months. Shoots them spam TV. Cedric, how are you guys doing? How is life? You are an IBM developer. Nice, nice. Whoa, that's big, man. That's awesome. Congrats. Now you're a cool kid in the block. Nice, man, nice. Well, yeah, I've been. You tried Next.js. Nice, nice. Obi, hey man. Yeah, it's been very long. It's been very long. I haven't streamed in 3 months, and my wife and kid are sleeping, so I just wanted to start kind of the streams again and see what we're gonna be doing. So basically, my idea is that we do the cluster, right? So let me actually, give me a second. I just set that up. Let me get this camera also here to the cluster. So essentially, as you can see, if you guys remember, this is my home Kubernetes cluster. You can see here in the bottom, these are 4 Raspberry Pis, which are directly plugged into my MikroTik router on the top, right? Well, we're not going to expose it now to the internet. I actually want to make a big course on this, and I want to learn while doing so. So it's rather about, if you guys remember, I started writing this guide on GitHub, right? I'm gonna share it here. Chica, my friend, right? So essentially what I want to do is, yeah, what I want to do is kind of maybe continue a bit with this, right? And learn as we go. So essentially what I would like to do today is, so you can see we have, maybe we can do it like this. So we have basically 4 Raspberry Pis. I have them in the cluster, right? So I can SSH into them, right? So you can see this is my, these are just my SSH aliases, right? But we have 3 Raspberry Pis. And let me just kind of give you a tour, right? And then if we do get nodes, kubectl get nodes, you'll see that there's actually 4 Raspberry Pis. This one over here, to the left, all the way to the left, this is the master node, right? This is the master node, and the other 3 to the right, they're the workers. So you can see this. So if I switch back here, this guy here, you can see it's a control plane master. So what I want to learn, what I want to do, Obi-Wan also very happy, Obi-9 also happy to see you here, man. So what I want to do, that's why I kind of continue streaming, is do something different than Programmer Network, right? Even though, let's actually smack that. Let's just, does this even work still? I don't know. Smadi, my friend, hey. And give me 1 second, what was it? The Streamlabs, right? Was the thing that we used for this bot, right? I don't remember, it's been so long since I streamed. So let's just go there, and then I'm gonna show you what we're gonna focus on in the few streams and what we're gonna learn together, and then hopefully we can land somewhere and having a good course. Give me 1 second. I literally need to get back into this. What was it? Authenticator, right? Yeah. Twitch 615-514. All right, cool. Let me just enable this bot. I think due to inactivity, it was most likely disabled. So where was that? That was chatbot, if I recall, right? Nah, no, it's not. What was it called? Event list, TipGo. What the hell is this, man? It was some bot, right? Back to dashboard. Cloudbot, yes, okay. So activate Cloudbot. I think that's the only thing we need to do. And then we can do this now, I hope. Yeah, nice, okay, cool. Well, alrighty, so let's define a plan, right? What we're gonna be doing. So if I just close these sessions for now, and we go Kubernetes. So of course I'm not a Kubernetes expert, and we're gonna do a lot more than just Kubernetes. So yeah, in the streams we're gonna be learning together. I have this README that I wrote long ago in the streams, right, and off stream. So we're gonna kind of go through that, and then we're gonna do some other things. So let's actually, what I'm gonna I'm gonna create some sort of a diagram here, a plan of the things that we're gonna be learning together in the next upcoming streams. At least what I'm gonna be learning. I don't know how much any of you will pay attention anyway. So what I'm gonna create here is I'm gonna say I'll just do like throw IO, something like this, right? Is Docker a prerequisite? Yeah, definitely. So basically, let me show you again. So if we go here to the cluster, right? So basically, it's a very bad practice to. So we cannot put a database, for example, as part of the Kubernetes cluster, because you generally don't handle things like databases in your cluster. So what we're going to be doing instead, we'll probably set up Postgres on one of these two Raspberry Pis to the right. As you can see, I have two hard drives. Let me actually show you the hard drives. They're just simple SSDs. Yeah, so as you can see, we have just tools like a simple, I have these old hard drives, I don't even care if they die. So we're gonna use them as the whole point of the next few streams, or many streams, I guess, is gonna be to really create a full-fledged end-to-end server. Because the fundamental difference, let's just switch here while I'm talking. So the fundamental difference between, let's say, GCP, Google Cloud platforms, K3, like the actual Kubernetes, or any hosted like cloud managed Kubernetes, right, is that you, of course, this is always what you want to use. So actually, if you need Kubernetes, you probably don't, but if you do need it, you would probably use GCP or something, right? But that's not the point. So the point here that we want to do is in the next upcoming streams, and then write this down in this, I really want to end up with this repository that's very comprehensive, is that we do the full end-to-end. So from low level, setting up the Kubernetes, which I did, and etc., to networking layer like NAT, network address translation, firewall on your router level. I'm going to show you now in a moment. Ansible, and other things, right? So how can we automate this? So a lot of these things is good to know. You will actually rarely host Kubernetes, you know, bare metal like this. You don't want to do that. You don't want to, that's a lot of work and costs a lot of money, like maintenance wise, time wise. So yeah, so what we're going to be doing is pretty much essentially, yeah, let's open that diagram up. So essentially, as you can see, we have, yeah, I mean, I'm going to document it all as this is already, there's repository already what we have achieved so far. And of course, we're gonna keep extending this. I really want this to be a very comprehensive, and then I don't know if I'm gonna record video course on it just by following this, but the point being is, of course, you don't have to have Raspberry Pis to do this. You can set up virtual machines that would behave as actual individual computers like this. The main reason why I'm using Raspberry Pis is because they do kind of behave as they are 4 different computers, right? So I just like having something tangible like hardware that I can actually see here, right? You know, I can play with it. If I mess up some SSH stuff, I can plug myself via Ethernet and fix it. So it's a different feeling, like having all the hardware, right? Of course, this hardware would have been ideal if these Raspberry Pis were powered over Ethernet PoE, right? So as you can see on the top here, I have these 4 white adapters which are basically powering the Raspberry Pis. Good thing about them is that they're very deterministic, so there's rarely power oscillations in them, right? PoE can often be unreliable because when you're delivering power over the Ethernet, depending on the router and router grade, right, that can oscillate a bit. But anyway, if I had a possibility to adjust something in this 4-unit cluster here, I really wish that I didn't need the top adapters, that they were just powered from the router. But then I would need to buy the router that costs probably 5 times more, because to get a router that actually has real PoE on all Ethernet ports, that is incredibly expensive, right? Okay, cool. So if we switch back here, so essentially, yeah, so we have the MikroTik router on the top, right? So we have MikroTik router on the top, and then we have basically the Raspberry Pis, right? RP1, RP2, RP3, and RP4. And I'm gonna show you now the setup: RP2, RP3, and RP4. And this guy is the master node, right? So this guy is master node, and these are all the worker nodes, right? Worker, let's just do it like this. Worker and worker. Now, of course, they're all plugged. So as you saw, as you can see here, there's like a mini switch on the RB3011. So we have some ports. So they're all plugged basically via Ethernet, right? So you could kind of illustrate that, like there's some ports. And actually, if I open Winbox to connect to this router, and we're going to speak a lot about this because, you know, fundamental part of every server is knowing the networking, computer networks, right? Setting up the DHCP, setting up the leases, locking the IP to be constant. So there's a bunch of stuff, right? And then there's NAT, which I haven't set up yet, but some of you might know it as port forwarding. Well, NAT is a little bit different. But as you can see here, right, so each one of my Raspberry Pis here has a static IP basically. So what you can do with the MikroTik routers is you can basically, once your DHCP server assigns the IP to the device, to the physical device that you plug into your router, you can see it here by the active host name. You can see if I SSH into the RP, you can see that the RP is indeed called RP1, right? So that's why my router recognizes. Like, once you do that, you can basically tell your DHCP server, hey, DHCP server, I want you to make I want you to assign a static IP. So of course you can assign the static IP on the device itself, as I described somewhere here, but you really need to tell your router, hey, do not issue different IP addresses to this device, always make it static, right? So if we go somewhere over here, you see I assign static IP on the MikroTik router, and then you can of course do this on each one of your Raspberry Pis. So if I do this, right, this is DHCP CD config. Here you would essentially do things like this, right? I'm not going to do it right now because I don't need to, because my router actually defines this. And the reason why this is important, right, is is that your router really defines your infrastructure, right? So you're not coupling these two. So your Raspberry Pi doesn't actually care what IP it has, as long as you can identify them, right? So if I would plug my phone now via Ethernet to this router, right, in theory, and this phone would appear somewhere here, right, I could say, you know what, I want my phone to always have the same IP. So for example, we can see this is probably my work laptop, right? Yeah, you can see that it also has a static IP. Okay, and then if we take a look at the ports, right, so as I was just talking about here in the diagram that we're drawing, right, so you can see here that we have all of the interfaces defined on the router here, the Ethernet interfaces. This is my fiber. We don't care about this. This is where the internet comes. It is the modem from the ISP, home LAN, and then you can see I have identified, so these are the 4 Raspberry Pis plugged in here. I have another MikroTik router, which is on top of this cluster. You can't see it on the camera, but you can see here that we have assigned interfaces to these. So essentially now we know that Raspberry Pi is in the port 1, 2, 3, and 4. And of course, if I would extend this cluster with an additional set of Raspberry Pis one day, I have a plan for that. So basically you can see this bottom part is empty, so we can smack 4 more in there if we need to eventually. Okay, so going back to this here. So as I said, we have some interfaces, so we can just pretend that these are the interfaces, right? And then you're saying, hey, this one is plugged here, approximately, right? This one is plugged here, this one is plugged here, and this one is plugged in here. So you can say interface RP1, ERP2, ERP3, and the ERP4. That's great, right? So that's and I'm not gonna throw the rest of the stuff, even though we do have 2 hard drives. So let's just say database. It's not really a database, but let's just say that this guy here maybe, and this guy here, I don't actually know how I plugged it. Let me check here on the video. What did I do? Yeah, so we have USB 3.0 hard drive. This one is plugged here, so it's 2 and 3. So essentially we're gonna have 2 hard drives there. So we're gonna host Postgres here basically, but not as part of the cluster, but just as part of the, so it's gonna be a Docker container that we're gonna somehow network with the cluster. So we're gonna tell the cluster, hey, there's this database somewhere, and we're gonna try to, I never did this, so I've never done this, so it's gonna be fun for us to learn, because this part, so basically what I wanna do, I wanna create some sort of replica or whatever. So I wanna create some sort of way to, whenever the data is saved in one drive, it's replicated to another. So we have 2 databases that somehow kinda, yeah, work together. I have no absolutely idea how to do that, but let's say here, Postgres and maybe Redis. Postgres and Redis. I don't even know the terminology for this, so let's just try to imagine terminology, because yeah, that's with limited knowledge, that's the only thing we can really do. Yeah, mirror. I don't know if maybe exactly, maybe that is a professional term. You're probably right. Yeah, I don't. Yeah, I usually, you know, you have things like sharding and replication and stuff. So so let's just do this. Let's call it mirror, right? But I think it's rather, so let's say here mirror. So eventually we're gonna, this is the software part, right? So this is the software and this is the hardware. Okay, now of course what we want to also do, right, because right now when I'm maintaining my Raspberry Pi, so for example I need to maintain the one to the right, the 4th one, I need to do SSH RP4, right? And let's imagine I want to do apt update, then I have to come here and do, and I have to do the same thing for every single host machine, for every machine, right? So what we want to do to fix that, we want to introduce Ansible. So we're going to introduce Ansible, and Ansible is going to help us to, we're going to create an Ansible playground, and in the Ansible playground, we're going to say, hey Ansible, update, do the apt update and upgrade on all devices at once. So basically Ansible is going to help us to automate maintenance of these machines. Leo, my friend, hey. So let's just call this automation, right? So that's what we're gonna do. I didn't set up Ansible yet. I don't even know which computer I want to set it on. So right now my biggest problem here in my home server is that I have this desktop from which I stream, so the one where I'm right now, and I have another computer right here. You can see it like shit. It's hard, but it's actually, yeah, here where my hand is. I have that one that's plugged directly into the cluster, so I have a laptop. So you could say that this could be a terminal, but since I'm streaming from this computer, I probably want to set up this as, so we need to figure that out. I'm not actually sure where to set up these Docker containers, because, you know, if something goes to shit on this machine, then I lose this sort of stuff. So we have Ansible. So we're gonna have Ansible, and then there are a few other things that we're gonna have that we need to do. So I think actually I found some articles online that we should actually read. I think so I found a super awesome blog by some guy this thing. So this guy, Drunken Net, this is the article that I found. This is super awesome. He's done a lot of things that I want to do as well. And actually, let's Craft, hey there. So let me just save this. Good to see you again. Yeah, it's been 3 months since I streamed. Okay, so if we scroll down, let's see what we actually want to do. So let me show you the long-term plan where I want to land, right? So let's start with why, right? So of course, always tools are useless if you don't know why you need them. So why do we want to do this, right? So why do we want to do any of this, right? I mean, it's a great question. So let's define some reasons, right? Let's define reasons why. I missed you guys too as well. So first, of course, learning, right? I think a lot of people today, a lot of younger people today, a lot of have a very surface level knowledge of things. It's not to blame anybody. It's the nature of the work. Things are abstracted out from us. But a lot of people don't know basics of computer networking, servers, or anything, because again, you are behind some. You know, you're using Vercel, right? You click some button, and Vercel does something for you. You go to AWS or GCP or Azure. You click 2 buttons and things work, right? But the way that it works, it really works like this. Like all of these things we're going to be doing, that's what it does underneath. It's just APIs hitting some endpoints, and these endpoints hitting some other endpoints, etc., right? So number one, of course, why we want to do all of this, and this is going to be a long project, is learning, of course. Number 2 is being able to let's say, create infrastructures in minutes. So what do I mean by this? So for example, I want to be able to say, hey server, I need an API, I need a database, and I want you to put this under a domain and SSL, and I hit enter and it all works. And we're gonna draw that in a moment, right? So basically I want to be able here at home I want to start a new project with you guys. In 3 minutes I want to be able to just spawn things like that. Yo, hey buddy, good to see you again. And we're gonna draw how we want to achieve this, right? Number 3, so is of course career, right? If you ever want to be a CTO, if you ever want to be a engineering director, CTO, team lead, engineering director, you need to know, at the very least, you need to know how things work, right? You don't need to set all of this up yourself, but you need to know how things work, right? Because you as a leader, technology leader, you need to be able to argue things with stakeholders, with investors, you need to be able to reasonably argue when you're talking to non-technical people. So you need to be able to say, hey, we want to we want to introduce Kubernetes, why, right? And in most cases, in 99.9% of the cases, you actually don't want to do that. So yeah, are there more reasons? Yeah, let's write them as we go. So these are the reasons why we want to do this, right? So why we want to do this? Well, this is why, right? Okay, so what do we want to do? So what it is, what do we have to do? Okay, so this is going to be interesting. This is going to be very complex, actually, and I'm very, very, very excited about that. So let's start from the output, almost as if we are writing unit tests. Hey, this is the outcome I want, and then you make that outcome come. So what do I want to do? Well, this is what I want to do. I want to be able to write some K3S template, and then once I apply the template, I want services defined in the template to be running. Cloudflare, I want to hit Cloudflare CDN and generate a CNAME or a CNAME record, right? Dynamically, or a name provided inside of the template. And I'm going to explain in a moment, right? SSL certificate needs to be issued automatically, right? So very important, right? So these are the basics of every infrastructure. We have some services. These services have to communicate with some world, so they need to be secured, right? So we need SSL, but we also need a domain. We're not going to be hitting an IP, right? So we need to be hitting the domain, some domain, something at dot whatever, right? And then I need to set up NAT on my MikroTik router. So this is also going to have to be done via the networking API. So basically my router, this one that you can see here, router board RB3011, will need to somehow figure out how can we use the API from the actual hardware and create some rule in there, right? So if we open this up, right? So this is all visual, right? This is visual GUI, but you know, we have a terminal here as well. What was it, right? So we have a terminal here as well, the MikroTik terminal. So you can see we can get inside of all of these menus and add the rules, right? So for example, if we take a look, MikroTik terminal commands, right? Command line interface, you can see that MikroTik, of course, like Cisco equipment, any professional grade networking equipment, obviously when I was working in 2008 as a Cisco engineer, I would never use this graphical user interface. Very rare, unless I want to see a list, whatever. It was mostly, I forgot a lot of these MikroTik specific commands, but you can see here like IP route print. So if we do IP route print, we're gonna see the IPs, right? So here we will have to eventually look into the API, right? So how can I call my API here and then automate this? So hey, provide credentials to my router so my Kubernetes can SSH into it or whatever, we'll see, I don't know, and then create some NAT rules or any rules needed for that given specific set of services, right? So if we are to draw this essentially, so this is kind of a big overview. Look, so why do we want to do it? What do we need to do? And then if we kind of draw it a bit, there's going to be Cloudflare CDN. There's going to be Cloudflare SSL, so security. We have MikroTik API, router API. And then of course we forgot one thing, right? So create databases, Postgres, Redis, right? So if you remember, we have these this hard drive. You can see it in the left. It's plugged here in the two middle ones. So we have these hard drives. That's where we're gonna set up our databases, our Docker images, right? Or Docker Compose maybe, or whatever. We'll see. I don't know. I have no idea, but it's a lot of work. Record dynamic template. So we have that. We'll have, yeah, databases, whatever they are. Actually, it doesn't really matter which databases they are. So would that be our goal approximately? And then we should find some infrastructure as service, right? So there's nothing hosted we can use, for example. Let's actually see. Most popular infrastructure as service. I don't know how to even search for it. Team City, nah. We can use, let's see what is the most popular today. Terraform is for sure one, exactly. Okay, so Terraform. What is space? Okay, well, these guys have put themselves on the on top of the list because it's their product. Vagrant. Vagrant is not really. Yeah, Vagrant is more for development. That's funny, right? It's like, yeah, we are the best. We are the best. Oh, I hopefully I have muted this thing. Have I? Yeah, I have. Okay. Okay, cool. So we'll see, but probably Terraform, right? So we need to figure out how can Terraform fit this thing, right? So we also need Terraform. Let's put it somehow here. Infrastructure as code, right? So how could we fit Terraform in here? Is the question. So this would be awesome, right? So we have Ansible, we have Terraform, we have K3S, we have a lot of things. So it would be a very good kind of project to do. To kind of get, of course, we're not going to become experts. Kubernetes is huge. And when I say K3S, of course, you have to understand what K3S is. So K3S is a lighter version of Kubernetes, right? So as you can see, it's something that can run on the edge, Internet of Things, CI, and ARM. So in our case, that's the case for right? The components of K3S are very similar or identical to Kubernetes. So you have some API that supervises everything. You have the workers, and you have the containers, and you have the pods. So knowing this is, I think, comes with time. It's not rocket science. It's just how these components actually operate. In fact, if we go to ChatGPT, let's just do this together. Let's just do this. Explain Kubernetes as I was 6 years old, right? Kubernetes is like, so let's kind of go through this together. Imagine you have a bunch of toys or boxes, and in each box there's different toy you like to play with, but instead of you having to find each toy and open each box by yourself, let's pretend there is a really smart helper who knows where every toy is and can get it ready for you, right? So that is when we're talking about supervision, right? Kubernetes is like the smart helper, but for computers, it helps different parts of computer program find each other and work together, even if they're in different places, right? So we're basically, even if they're in different locations physically or virtually, doesn't matter. So if you have one toy car in one box and some blocks in another, Kubernetes makes sure you can play with both without needing to look for them separately. It makes it easy for, so basically it's orchestration, right? Explain each component. So this is very important, understanding these components. I have already kind of did this with right? So let's see. So master control plane, This is like the toy manager who knows where every toy is, keeps everything organized, and decides which toy should go where. The master job is to tell everyone else what to do. So yeah, you have an API basically that's responsible. You can see API server, the request handler who listens to what you ask for. I want my toy car, and makes sure your request goes to the right place. Scheduler, the toy planner who decides which box has room for new toys. It's almost like a load balancer of some sort, right? It's like figures out. So because this guy is the brain of the operation, it knows the load of all of the other things. So it's like, hey, I'm not gonna send this task to this guy because this guy is already doing way too much. Let's find one of the other ones that are not doing so much. So it's almost in a load balance in a way. Controller manager, the fixer upper who watches over everything to make sure toys are where they should be, and if anything's missing out of place, it helps fix it. And then there's this process, the memory keeper, who remembers where all the toys are and keeps track of every change. So it's basically a database, you could think of it, right? Temporary database. Nodes, workers, so these are the actual important guys for us. These are the guys where your services will be, right? The helpers are like little workers. Each node is a box where you can put toys. They listen to the toy manager and get ready to play with the toys inside. The box manager makes sure all the toys in the box are in good shape and doing what they're supposed to do. If one toy breaks, Kubelet can help fix it. So we have the nodes, we have the pods. Each pod is like a little package with toys. So basically pods, if we go actually over here, if we actually go to if we take a look at the diagram of Kubernetes, in fact, I think it's a little bit better. So if we go over here, so you can see actually here, let me open this in a new tab. So you can see here we have a worker node, and then inside of the node we have the kubelet, we have container runtime. Again, it's overwhelming. It's overwhelming for me as well, so don't worry. It's not that I'm an expert at this, but it's over time, right? So you can see the worker basically is encapsulates some of these components, right? So if we go over here, each node is box where you put the toys, right? And then it has some, and then pods. Each pod is like a little package with toys that work well together. Maybe you have a toy car and some blocks in the same box because they're part of the same game, right? So it's now referring to the services, right? So, and then the services here, this can be misleading in the context of Kubernetes, right? But services essentially are a way for us to define the exposure, who can talk to what, the access, right? So you can see services are like map helpers. They give toys a name and make sure you can always find them even if they move around. So, but also services are there, right? So we're going to use a service, for example, we're going to use Ingress to expose our server through our router to the internet via Cloudflare, right? Namespaces are basically just a way to group different services, and then Ingress and stuff, we're gonna take a look at that. Actually becoming overwhelming, which is why I'm actually doing the same thing, but starting off with one node. I put the Ubuntu server on it and I bricked it last night after a long day of work. I run sudo. You're gonna do a lot of that. So my suggestion for you, Stevie, is that so what I did, I think I also wrote it in this guide. So make sure that you use a Raspberry Pi. I'm sure that you did that, but make sure to use the Raspberry Pi manager, right? But make sure to choose the light operating system. So go to the Raspberry Pi here, Raspberry Pi OS Other, and then use the OS Lite 64-bit. It's very important to do that. So don't install the actual Ubuntu, like the full-fledged desktop, because of course so this is a light version just without any graphical user interface, right? And then make sure that when you put in the SD card, that I actually don't have an SD card that I can show, but yeah. And also, yeah, you have this thing as well. So feel free to, if you find it useful, to take a look at it. Okay, anyway, so this is the K3S. Again, it's a lighter version of Kubernetes, right? That's really what it is. And then, yeah, as I said, I found this work from this guy, so this is going to be awesome for us. Okay, anyway, so for today, for this stream, I think what I want to do, let me save this. Kubernetes course. It seems that okay, so I already had this overview. Okay, I'll delete this one. Yeah, this one I actually already have. I didn't even know. So let's go here and let's rename this to plan. Something like that, maybe. Okay, cool. All right, so now the question remains, I want to set up Ansible as the first thing so we can manage these Raspberry Pis easier, right? So because again, as I said, every single time. So let's take a look at Ansible together. I've never used Ansible. Actually, I did when I worked at the Technical University of Denmark, but that was 5 years ago, so I don't remember much. So now the main question is, right? Let's just write some notes down, just some sort of a monologue, or yeah, whatever, questions. So when it comes to Ansible, should we install it directly on this host or inside of or as a Docker container, right? Because if we install it as Docker container, then I will have to do some networking here. So then also, yeah, I don't know. What is my plans with the hardware? So this stream, I haven't streamed in 3 months, but this stream is about programmer network. So basically in this stream for a while, I've been building this programmer network platform, you know. And this programmer network platform right now, it's hosted on Hetzner. And for example, maybe one of the first use cases, if this turns out well, is I would move this and host it at home here, right? So as you can see here, I'm paying 21 euros for Hetzner, and I have fairly complex infrastructure, right? With Prometheus and Grafana and a lot of different things, right? So there's really no majestic plan. The plan is to have, basically the plan is to, the plan is really this, right? To enable oneself to create infrastructure very fast whenever I need it, right? And you know, I'm gonna of course stream for many years. It's just I'm on and off. I'm not a typical streamer. I stream when I want, then I disappear for a long time, then I come back. But for example, one use case is when I'm streaming, I can just you know, I can just spawn infrastructure and we do a different project together. I expose it so you guys can use an API, etc., right? Of course, this is all for me personally. It's rather like it's very hard today to get any job where you do these things on a bare metal. This is almost dead. This almost doesn't exist anymore, right? So this is also a way to have something to maintain. And you know, I'm not a system admin or DevOps guy, but I've been doing servers for 20 years, right? But it's as the time goes by and as we are more, you know, at work, we use GCP, Google Cloud Platform, we are further and further away from bare metal, right? Which means, you know, we keep forgetting these things. So it's also something to have to play with, to break, to fix, to write. I think it's very important to at least for me, to have something like that. So let's just say it's very impractical. So if you want to host things, you definitely don't want to host them at home. You definitely don't want to do all of this work. You want to, as I always say, you want to build a product. You want to build products. Nobody cares about infrastructure. Users certainly don't care about, nobody gets impressed that your website is fast, right? Because that is considered. That's why you know, after 2008, I stopped doing Cisco. I used to work as Cisco engineer. Why? Because it's the most ungrateful job ever, right? As I was saying before, nobody's impressed that your internet works, right? It's like, it's very considered. It's like, wow, these networking engineers, they're so good at making so it's the same with infrastructure. It's a very ungrateful job in a sense of like, people consider that to your service to be up and running and always working fast, right? So What do you think about this? Exactly. So that's pretty much, let me see. Let me actually see what this is. It's a router of some sort. Give me a second. Give me 1 second. Confirm you're a human. Well, I don't know that. Am I a human though? What the fuck? They have their firewall is and it's a router, right? I suppose. Oh, I've been blocked. Okay. Terminal. Okay, HP. I don't know, here in Denmark it costs like 500 euros or something, so I'm actually not sure what's happening. I cannot find it. But it depends what do you need it for, right? I mean, so for example, like for like the thing is, so the biggest, so if this is a router, right? It depends what do you need it for. Like MikroTik and Cisco and maybe a few more brands you could say that are professional grade enough that you have all the possibility to it's a mini PC. Yeah, I don't know, maybe it is a mini PC, but when I see 8 gigs of RAM, that's not sufficient, right? That is 8 gigs of RAM technically is only sufficient to listen to music and browse stuff, etc., right? So if this is a computer, then the answer is definitely a no, right? You need at least 16 gigs of RAM or more, preferably, for any serious work, right? So if you want to buy this as a computer, then my answer is no. But I don't think it's a computer because he says it costs 50 euros. So I don't think you can buy a computer for 50 euros. It's probably some sort of a router. Yeah, it's maybe this one. I think it's this one. Yeah. Or no. IoT and I don't know actually. So it's probably, so it is some sort of a mini computer, I guess. Yeah. Hey Stevie, thank you, man. Thank you for the follow, man. It's good to be back streaming. So yeah, I don't know. Like, you know, whenever people ask me, I never give absolute answers or any answers on anything until I know the context, right? So if something is good and bad, always, absolutely always depends on the context. What do you need it for, right? So it's very hard to say. Very hard to say. Okay, so let's learn Ansible, right? Or relearn Ansible. Ansible automates the management of remote systems and controls their desired states. Yeah, so we have Ansible inventory, and then we have computers, right? So essentially, again, just to illustrate it visually, right? So the reason why we want, so right now, let's define the problem and then the solution to that problem. Right now, if I want to manage my 4 Raspberry Pis, as I said, I need to SSH into every single one of them, as I am now, just as an illustration. So 4 of them, right? And now if I want to do just the basic stuff, I want to echo something or print it or do an apt update, I have to repeat the same thing every single time. Essentially, even if you go to this Kubernetes guide that I wrote, a lot of these things could have been automated with Ansible. So this guide eventually could start with Ansible. So hey, even this flashing the cards for Raspberry Pi, okay, that we can't do with Ansible, but everything below, disabling Wi-Fi and doing all of these things, in theory could be multiple Ansible templates, right? So for example, because there are multiple restarts involved here, and I don't know Ansible sufficiently enough to make any claims yet, but I don't know if Ansible template or whatever, inventory, whatever is it called, can do something, restart the host and then continue. Like, I don't know if it has some state where it says, hey, I have this template, and inside of the template there's a step where I have to restart for these changes so far to be propagated or applied. So I don't know, but either way, a lot of these things with Ansible could save so much time, because I literally had to do all of this one by one. So as I was writing this guide, I would SSH into 1, 2, 3, 4, blah blah blah, right? Sodium, hey friend, we are setting up, I mean, we're going to be working on this cluster of mine here, the Raspberry Pi cluster. You can see 4 Raspberry Pis and router. And yeah, we now want to, today we're going to, I mean, I just gave, so far in the stream, it was just an overview of what we're going to be doing. I haven't streamed in 3 months. And I gave some ideas for those who care. And now, yeah, I want to start with just, it's not really a cluster related work yet, but it's rather just automation on the, actually it is to some degree. Creative Dreamer, hey buddy, good to see you. Not much, we're just playing with my local server here, and we're trying to learn things together. I would say maybe run Ansible from a local PC and all the P's out to the host file. I think that, yeah. So it's just, yeah. I mean, that is the thing, right? The question is, should I run the? So I think what would be probably better, right? Is that this guy here? Is that we host it on a? Is that we run it as a Docker container? Or even better, to create our own Docker image, right? That we publish to either GitHub, or I'm paying for Docker Hub. Because this way, right, all the configuration and stuff we could keep inside. The alternative that you say is definitely simpler. So what you're suggesting is simpler. Just, you know, install on host. But then if this computer goes to shit or whatever, which is very unlikely because this is like a 10,000 euros computer, still, I don't know, we are so far from installing things, you know, due to Docker. Mauser, good day, buddy. So I don't know, I much rather would like to do this, but then let's see what the implication of that would be. So if we do this, then I would have to bind the port of that container to some local port. Let's see, because we would need to, how would we then run these Ansible commands? We would have to so Stevie, I think somewhere I have because you're new to the stream, this stream used to run almost every day. I used to stream for a year. But I have, we have a huge backlog. So as I said, Programmer Network is what we usually build in this stream. It's actually, you can sign up if you want. It's literally program. But somewhere here I have a hub Docker. So you can see here I have a task that I wrote October 2023, move from Docker Hub to GitHub. And that is mainly because of COGS, costs of goods sold. I mean, I'm paying for Docker Hub $10 a month. Who cares? It's like one coffee here in Denmark. But it's about being smart rather than, so yeah, so don't worry about it. It's money is not the problem. That is not the problem. Give me 1 second. Let me just drink some water. 1 second. And actually, we should probably, I suppose... Yeah, never mind. But actually, Stevie, please, man, like any suggestions? I mean, I stream literally because if I find it fun or whatever. So let me just see how. Yeah, it's every suggestion is good, even if I remember. Even if I remember just the tool name, it's sufficient enough. Nice, nice. Ah, okay. No, this is awesome. Well, I think this is why not? Let's just put it somewhere. Let's put it here just as so let's say here. Right, so we're gonna do that like that. Okay, cool. And then there was another. Okay, so where was I going? Okay, so yeah, we wanted to take a look at the Ansible. Before we do so whatsoever, so as I said, just to repeat again, so I found this awesome blog, and this guy did a lot of stuff that I want to do, that we want to do. As you can see, he installed Nginx Ingress on K3S. So he said, he did a lot of things. I found this, I believe, 2-3 days ago. Installed Cert Manager, so a lot of these things are going to be useful for us as well to learn and then extend on. So this is super nice. Additionally, I spoke a little bit to ChatGPT. I actually don't remember what I asked it. Let's see together. So we'll probably need to set up Helm as well. But then no, that's not what I wanted. That's not, no. This is not what I wanted to show. Give me 2 seconds. So we'll need to set, yeah, so we'll need to set this is an Ingress, I believe, yeah. So this guy, I don't know yet, but we'll need to set this load balancer, because apparently the built-in one isn't great for bare metal that we have. It's great for cloud services, GCP, Azure, and AWS. So it's a lot of crap. We need that, we need, but no, Kubernetes local development. There was some tool that I found that I want to set already soon. Let's actually ask. I have my own, I'm using OpenAI key, so I have my own instance of Globe Chat. This is ai.programming.network. So let's just ask here, what is the name of the tool that enables good developer experience for Kubernetes? Yeah, Stevie, I have all of that for Programmer Network as well. So for example, if I go to Grafana Programmer Network, let's actually go to Cloudflare very quickly. So I'm using, I've set that all of that up. I'll actually show you in a moment how. I need to. So I did set all of that up. Actually, if we open up. So the Programmer Network project, which this stream is really about, is I'll be very quick, really looks like this. So this is my Programmer Network infrastructure, and this is also kind of bare metal, it's just on Hetzner. So as you can see, I have a lot of stuff here, but you can see over here I have the whole, like I call it, internal services. I have Grafana, Prometheus, Node Exporter, Postgres, CertBot, Google Cadvisor, Alert Manager. And then I have other services. So absolutely, actually, what I'm gonna do now is just go to Programmer Network here, Security, VAF. Interesting. So if we go to IP addresses here, manage list. We remove existing ones, and then we add the items. Bam. Hopefully that is gonna propagate fast enough. Yeah, there we go. Yeah. But it's maybe it's a caching issue here. Yeah, we'll wait a second, but I'll show you that thing. Yeah, tilt. So this is what I found. Yeah, so this is what we also want to set up as part of this. So let's actually add. What does K? I actually don't know. So please do not consider me an expert in K3S or Kubernetes at all. Quite the opposite. The whole point of this couple of streams is going to be that we at least get close to some reasonable experience. Rebecca, oh my God, you came to my mind several times past 3 months, especially when this New World thing was released. I'm like, I wonder if she's playing that stuff. Good to see you, friend. Good to see you. Okay, good. I'm like, she's gonna play that. No, I did not. No. But yeah, I didn't stream in 3 months. I was focusing on other things. Yeah. So hopefully we can, yeah. Okay, so yeah, so here's our Grafana and Prometheus for Programmer Network. So as you can see here, we have a bunch of metrics. I'm going to be very quick because I want to focus on other things. Then we have the API logs. Here. Let's see if there was any errors past 7 days. Yeah, man, exactly. Very good. Okay, good. I'm like, is she playing or not? Alrighty. Okay, great. So now let's now focus a bit and actually hopefully do some. I don't know how long I'm going to be streaming. It's been very long since I streamed, so probably not for too long. So Ansible again. So let's try setting that up. Ansible. Let's go to their documentation. "24-hour stream." Maybe, who knows, one day we maybe set up your development environment, learn how Ansible works, understand fundamentals. Getting started with Ansible, okay. So we're gonna do that pretty much. So I'm gonna stream. So let's say here, stream 11/24. Oops. All right. So Ansible automates management of remote system and controls their desired state. Managed nodes, as shown in the preceding picture, most Ansible environments have three main components. Control node, the system on which Ansible is installed. You run Ansible commands such as Ansible blah on control node. Okay, so our own computer here is going to be a control node, right? So control node, my own computer. Almost like we would call before in old times a terminal, right? Inventory, a list of managed nodes that are logically organized. You create an inventory in the control node to describe host deployments to Ansible. So the inventory basically is a list of managed nodes. So this is, I guess, the metadata about, or the things that we will do to the managed nodes. So managed nodes in our case are going to be Raspberry Pis, or in the future I have a bunch of old computers and bunch of computers. Generally, we might plug in more machines to this cluster eventually. So, but yeah, so that's what they would be. So open source Ansible license. Is it really open source? Like open source, always be careful about open source, right? It's very imperative. Open source can mean a lot of things, right? Do they have the license here? Let's see, are they actually open source? They are. They're MIT, okay. So they are actually open source. Okay, good. Using Ansible lets you automate virtually any task. All right. Here are common use cases. Eliminate repetition this is exactly what we need. This is what we need. Nah, probably not, but potentially. So we could say that we want to install the same thing on all hosts. Yes. This I can't comprehend yet. I don't know how they do this. Ansible uses simple human-readable scripts called playbooks to automate your tasks. Cool. You declare the desired state of your local or remote system in your playbook. Ansible ensures that the system remains in that state. An automation technology, Ansible is designed around the following principles: agentless. And this is really awesome, right? So what this actually means is that this is very good, right? So in typical automation tools like this, you have some computer like mine now that controls everything, as they call it here, right? Control node. But then you have to install all of these agents on the host, on the remote machines or any other machines, so they communicate. The good thing about Ansible, I think that's probably one of the biggest selling points, is that there's nothing really you install on the actual remote machines or the hosts. You basically just described here on your control, on your main computer, using these templates or whatever, playbooks. Hey, I want to do this on these machines, right? Yeah, that's amazing, Stevie. That's amazing. Hopefully we can even do that consciously, explicitly once, fail purposely just to see how that works. That would be awesome. Simplicity automation playbooks use straightforward YAML. I hate YAML. JSON would have been better, but it's fine. Automation playbooks use straightforward YAML. It's decentralized using SSH with the existing OS credentials. Very good. So so far that's great, right? Very good. Scalability, easily and quickly scale the systems you automate through a modular design that supports a large range of operating systems. What does this mean? So basically it's pure, basically, you could say, right? Yeah, for sure, Stevie. I know also also with the Terraform and stuff. Yeah, GitHub Actions as well, you're right. Idem.
Idempotency. Idempotency.
Idempotency. How the fuck I've never heard about this word.
Idempotency. Idempotency.
Oh, okay, interesting. Idempotency. An API call or operation is idempotent if it has the same result no matter how much. So it's basically yeah, okay, got it. Yeah, but it's the same. It's kind of, yeah. It's basically almost like purity, right? Given the same set of input, it's always going to yield the same output, right? It's just, yeah, they shouldn't, yeah. When the system the state the playbook describes, it does not change anything even if the playbook runs multiple times. So that's what they mean, right? So if you run the same, which is logical, why would it, right? So if you run the same playbook 5 times, if the state is the same, it's going to remain the same. I mean, of course, I mean, that's needless to say, right? Okay, so now the question is, how do we install this? Should I install this here on my computer, or should I have a Docker image where I set everything up? That I don't know. How do we do Python version? No. Do I have py? No. Pip. Well, I can't because... Alright, that's weird. Okay, so we do have Python, right? So we could, in theory, just to learn this, say pip install Ansible. So let's do that. And I need to think a little bit about this. I don't like installing this on my machine. I just don't like that. All right, so let's add these things to the path, right? And right now we are in ZSH, right? Yeah. So let's say v ZSH RC, right? Wow, that is super weird. Crap. Yeah, that's... Yeah, how come that we don't have this in the pad? That's so weird. Okay, so now if I do Ansible doc, right, it should find the binary. Yeah, okay, good. All right, so let's add all of these things, right? So let's not forget to... So let's create a different README here. Setting up Ansible, and then I'll clean it up because I want this repository to be awesome. I really want us to make the most amazing repository ever. And I'm not kidding, for this type of stuff. So by the time in one day when we're done with this, I want somebody to go to this repo and be able to do everything we did. All right, starting with Ansible. To get started with Ansible, the best start with Ansible. Check out the official getting started guide. Once installing Ansible, in order to install Ansible, you will need, in case you don't already have it, you will need to install Python. After that, I'll read proof this using ChatGPT Ansible. You might get a warning like I just want to do this as a All right, cool. So that's how far we got. Great. Then we continue. Create a project folder in your file system using single directory structure makes it easier to add source control as well to reuse the shared automation content. Okay, I see. So basically what we're gonna do, I'm gonna say create a directory called programmer network Ansible create a project folder. I don't know actually if I should even be adding all of this. Okay, continue getting started with Ansible, building an inventory. Okay, this is now actually going to become, I suppose, more practical. Inventories organize managed nodes and centralized files that provide Ansible with system information and network locations. Using an inventory file, Ansible can manage a large number of hosts. Nice. So let's open up this folder now that we've created, Programmer Network Infrastructure. To complete the following steps, you will need IP addresses or fully qualified domain name of at least one host. For demonstration purposes, the host could be running locally in a container or virtual machine. Create a file named inventory ini. So let's do that. Let's move this here. So we create an inventory, okay. Add new hosts to the inventory, blah, blah, blah. Okay, so we're gonna do this, and we can do this, right? So I'm gonna do this. And then we're going to go to our MikroTik router over here, and then we can see the IP addresses of all of our things, right? So we can see if we sort them out. So this is our Raspberry Pi 1. So can I write comments here? RP1. This is our RP2. 241, right? Yeah. RP3, and then RP4 is 240. Okay, cool. That's great. Okay, what next? Verify your inventory. Okay. So let's maybe yep. So, and what does this do? Verify, ping my hosts in the group. Okay, so let's try to ping all of the hosts defined in this inventory. Unreachable, okay. Oh no, actually, wait. Failed to connect. Oh, okay, but why does it? Ah, okay. What? It's actually trying to SSH into there, no? Yeah, actually I can see, but that's weird. Why is it trying to SSH? I mean, it doesn't need to SSH to ping them. It should be literally calling the ping, right? No, it's okay. This is the learning moment, right? So yeah, so clearly we need to set up SSH, right? To make sure backdoor is installed, exactly. My hosts, okay. It's an Ansible ping. I see. Okay. Makes total sense. Let's actually turn this into a YAML file, right? So we're gonna do this because I know that we're gonna be, as Steve said, we're gonna be writing a lot of YAML. So better that we just. So here we're gonna say RP1. Come on, Copilot, you can do it. Come on, dude. So weird. Okay. And then I guess next step is actually setting up SSH, right? So oops. It's 40, right? Yeah. Okay, so that's good. My hosts. Okay, that's weird syntax. Okay, so so let's go here and say actually no. Let me open my own OpenAI stuff. Setup official Ansible documentation is missing. Setting up SSH with Ansible in the initial steps. Please provide me with information how to do so. Oh, should I actually know what the problem is? Because when we run this ping, I think it's using the wrong username, I believe. I think it's using AGJS, and it should be using Alexander. Yeah, maybe. Okay, let me ask. How can is there an argument that I can pass to tell which user name to use with SSH? I guess so, yeah, I guess so. Ansible user, yeah. Yeah, exactly. So this is the issue, right? Because I already have SSH set up, right? So here I need to say Alexander, right? There we go. Now it works, right? Okay, good. So we can see that Ansible, in fact, can reach. That's what we wanted to confirm now, right? Can Ansible access our hosts, our Raspberry Pis, these guys here, right? And as we can see, it actually managed to do so. That's very good, right? That's very good. Yes, there's an argument that you can pass to specify which username to use when connecting to a host via SSH. Here's an example of how you would specify blah blah blah. Ah, this is also nice, right? I like this more. So this is what we're gonna do, right? Very nice. So if we go to over here, right? So we have the host and we have Ansible user, right? So of course this is something, and then we can eventually have environmental variables, I hope, or whatever. So that's gonna be nice. So if we do this now again and omit the user, it should still do the same thing, right? Yes, it does. Nice, nice. Okay, very good, cool. So yeah, going back to the official guide, Ensure that the group, so tips for building inventories, ensure that the group names are meaningful and unique. So I guess group names is this my hosts, right? So I guess here we can say Raspberry Pis, right? And that should still work. That's a group, right? And then my host here should be Raspberry Pis. Nice. Okay, so this is called a groups, right? So let's just say groups. A group name. Cool. Okay. Avoid spaces, hyphens, and preceding numbers in group names. Group hosts in your inventory logically according to what, where, and when. Group hosts in your inventory logically. Okay. What? Group hosts according to topology. DB web. Okay. I see. Group host by geographic location. Group host by stage, development, test, staging. I see. Okay, cool. Let's in fact, because we're learning, let's smack this URL here so we can quickly get to it. Okay. Create a meta group that organizes multiple groups in your inventory with following syntax. Yeah, but what? Yeah, this is a pretty terrible guide. In a like, oof. Yeah, I don't know why they do this, right? This is very poorly written. Like you start within like 7 seconds ago we installed it, and now they're talking about meta groups and setting up data centers. I mean, come on, man. Like, you know, chill out a bit. Yeah, I mean that is yeah. I don't know why. That makes no sense. Give me 2 seconds. I just have something to check. All right, cool. Yeah, right. Variables set values for managed nodes, such as the IP, operating system, users, so you don't need to pass them. Yeah, so that's what we just did. Ansible host, HTTP port. So that's good. Okay, so what's next? Okay, create a playbook. Playbooks are automation blueprints in YAML format, a list of plays that define the order in which Ansible performs. So basically, yeah. Okay, play an ordered list of tasks that maps to manage nodes in an inventory, a reference to a single module that defines the operation. Okay, let's get practical. Create a file name playbook YAML. So let's do that. Playbook.yaml. I see. So these hosts here, right, is the group that we have here, right? Ping my Ansible built-in ping. So these are some sort of functions that they're executed, right? So if we do this now, we can also do it here. Playbook YAML. No host could not match supplied host pattern. Raspberry Pis. It's because, Oh yeah, exactly. What I'm passing here, right? Let's actually open this. You're absolutely right. You're absolutely right. And another typo. Cool. Okay, great. So let's see what happened here. Let's analyze this. So we provide an inventory, and then we provide a playbook. So inside of the inventory, we have defined our hosts and stuff like that and groups. And then the playbook says, hey, I want to run my first playbook. I want to run it for these hosts, and these are the tasks that I want to run for these hosts, and these are, I guess, some built-in, we can see here, some built-in tasks. So I suppose we're going to be writing our own tasks, which we're going to be. So this is basically a function that takes some argument, right? So this is almost like you said function debug, and message was an argument that it got, right? So this is just the way that YAML works. You need to nest these things, right? Okay, cool. So we have tasks, then we, in a synchronous way, define, run this, and then run this, and then run it for these given hosts. Very easy. Okay, very nice. In this output, you can see the names that you give the play and each task. So let's see. So gathering facts. Becca, hey there. It's been 3 months, yeah, since we saw each other. So what is this gathering facts? So I guess it's trying to figure out, is everything fine with the hosts? I guess it's trying to see, are the hosts reachable or whatever. Then it's pinging the hosts, and then it's basically piping that output to built-in debug, right? So essentially this is almost like ping and then debug, right? Just passing the output from the previous function to the next one, right? So that's what's happening. The gathering facts task runs implicitly. By default, Ansible gathers information about your inventory that it can use in the playbook. The status of each task has a status OK, which means it ran successfully. The play recap that summarizes the results of all tasks in the playbook per host. In this example, there are 3 tasks. OK indicates that each task ran successfully. Okay. Cool, cool. The machine, okay, these concepts are common to all users of Ansible. You should understand them before using Ansible or reading the documentation. Control node, the machine from which you run the Ansible CLI tools. So that's this computer from which I'm streaming. You can use any computer that meets the software requirements as a control node, laptops, shared desktops, of course. Managed nodes, also referred to as hosts, they're target devices. Yeah, so these are the things we are managing. A list of managed nodes provided by one or more inventories. So your inventory can specify information specific to each. So basically an inventory, right, is a way for us to describe our managed nodes, right? So in an inventory, we say, hey, there's some machine that I named the Raspberry Pi 1. This is its IP. This is its user. And when you try to SSH, do, you know, SSH, Ansible user, Ansible host. So that's at least what we have. And I'm sure that these files here will grow in complexity when needed. So just for my own sake, there's a control node. There's an inventory. We have hosts, we have managed nodes. So we have inventory, then we have playbooks that we basically define, and then we run those on the managed nodes, right? These guys, so playbooks contain plays, which are the basic units, right? The main context of Ansible execution, this playbook object must manage nodes, hosts to tasks. The play contains variables, roles, and an ordered list of tasks. So basically, Yeah, these are, yeah, but our tasks plays, is that, no. Because where the concept, where is that? Roles, plays, yeah. The main, so I guess the play is the playbook YAML file, I suppose, right? So that is what's called a play, right? So this file is a play, and then it contains tasks, roles, and handlers. A special form of task that only executes when notified by previous task, right? Yeah, so that's piping. So handlers gets the input from the previous one. Modules, the code or binaries that Ansible copies to an executes on each managed node. And then there's some plugins. Okay, it's too much theory. Let's move on. So this is talking about containerizing this in Docker or whatever. Ansible tooling. Setting up your environment. Let's see what a... No, actually, so I think so far we got enough. So let's now actually be a bit more practical. Generate a playbook that will do an apt update on my hosts. But because I don't need more complexity than this now, right? It's light version of Raspberry Pi Ubuntu 64-bit. So yeah, I can see that. Okay, let's try that. So we're gonna do something like apt update dot. So let's do like apt update dot playbook. I'll just invent my own naming convention here, dot YAML, just so I know it's playbook, or just put it in a playbooks. So we do this, we move it here, and let's see now what happens. So it has built-in function for that. Update all Raspberry Pis hosts. We're gonna specify Raspberry Pis. What is this become? What is become? In Ansible, become is an option that allows tasks to run with elevated privileges, like sudo. This is especially used for tasks requiring... Okay. Nice. Okay, cool. All right, so now if we try to run this, inventory is there, and then we have playbooks, and then this guy. Okay, nice. So it actually did something. Let's see. Can I actually SSH into RP2? Because I think it's actually now doing the upgrade on these three. So I think this is already awesome, right? This is an example. This is an example how we can install Vim. So this is already like pretty good, right? So I think to recap, we have an inventory where we defined our host, and now we have playbooks basically. I'm gonna remove this one because it's a dummy one. And now we have playbooks like this, and we can basically, that's pretty awesome. But why is this stuck? Upgrade all packages. Maybe it's waiting for each host or to finish, right? SSH RP3, SSH RP2, SSH RP1. Okay, so great. Okay, good. So if we take a look at this, it actually executed the command in each one of them. So let's actually test that. So if I do sudo apt update, it should really be up to date already, right? Yeah. And this should also return nothing, right? Yep. Let's do the same here. Yep, so it worked. Awesome. So great. So we learned some so we have learned some Ansible. It's literally that simple. So now, of course, if I wanted to do this on a remote Hetzner machine, right? I would just provide I would need to copy my public key to Hetzner, which I already have. And I would need to provide the IP of Hetzner and the user. So yeah, you can see how you can, in a very distributed way, Ansible Vault. Okay. Yeah, we use this also at DTU. We also, I remember. So where do you think, Ed, where do you think we should go next? So this is super nice already. So this enables me to do what I wanted already. So what should we do next? So basically in the Vault is a secure, basically encrypted place where we can keep our environmental variables, public IPs, SSH. So, okay, so let's maybe be a bit practical instead of reading the whole documentation. How do I set up the Ansible Vault and store my IP addresses and inventory in there? Okay, interesting. So Ansible Vault creates secrets YAML. You'll be prompted to set up a password. Inside secrets YAML, you can store sensitive data, encrypt the existing inventory. Completable dev. Hey, buddy. Good to see you, man. It's been months since I've been streaming, which means months since I saw you. How is life, man? Thank you very much, man. Good to be back in some shape and form as well. Okay, so encrypt the existing. Okay, so this is very interesting, right? So this is very easy as well. Which is awesome, right? So essentially, what we are saying here: create a new encrypted file. It's gonna ask me for a password. Inside secrets, you can store all the sensitive data, right? Encrypt the existing inventory. If you already have an inventory and you want to encrypt it, you can do this. Use the encrypted inventory, ask vault pass. Okay, so for now, but this is very interesting, right? So for now, I mean, okay, let's actually copy this as part of our guide. Let's go to this thing here. Setting up Ansible Vault. This is just, and then I don't know why this formatting sometimes gets messed up. So weird. Okay. If I do this now, okay, never mind. I'll do that another time. Encrypt the existing. Okay, I'll leave that as such. It's just for the notes, and then I'll recap that. So we install that. So what do? We install that. Blah blah blah. We fixed that path issue. We created the project, and then here we are basically missing to say to create an inventory and then create playbook. So let's just add that, and then I'll fill it up another time. So here I'm gonna say to do showcase, create an inventory, create a playbook, explain relations between control node, manage nodes, playbook, tasks, rules, roles, etc. Right? That's what I memorized so far. All right, I'll do that. Cool. And these are the notes that we made today, right? Yep. Alrighty, so if we go now to Kubernetes README and we scroll a bit down, yeah, so we'll need to now figure out, now how do we want to execute this plan we drew here. So if I close that stuff there, so essentially we need to figure out how do we, so we'll need to deploy some services to Kubernetes. Let me just write that down. So let's say create a K3S template that, we also need to set up Postgres on some of these Raspberry Pis, right? So create a K3S template that will set up, I don't know, a Go API, Postgres Redis database, generate a DNS record in Cloudflare. So we need to Cloudflare DNS API. it could be this one, right? So we could call this somehow. I don't know if it's a record for a zone. DNS firewall will also, I guess, need that as well. DNS settings, show DNS settings, settings for an account. So it could be this one, create a DNS record, right? Then we need SSL somewhere. Universal, automatic, custom SSL, SSL, universal let's ask ChatGPT. How could I enable a full strict SSL inside Cloudflare for a given DNS record in Cloudflare using the Cloudflare's API? Retrieve the zone ID. Shit, yeah, okay. So let's just write this down as well. So we'll go, I'll just smack it up here. Setting up Cloudflare SSL via API. So we'll just leave that as such. And then lastly, I guess, and similarly, I would like to create a DNS record when I apply a K3S template. So for instance, if I provision an API with a database, I would like to expose that API over some custom random dynamic CNAME or similar. That's at least the idea. To dynamically create a DNS record such as CNAME or a record in Cloudflare and provisioning an API in Kubernetes, you can use external DNS along with Cloudflare API. External DNS is a tool designed to manage DNS records dynamically for Kubernetes resources. Nice, okay. Install external DNS in your K3S cluster. You can deploy external DNS with Helm or using Kubernetes YAML manifest. If you have Helm, install external DNS. Install K3S on Raspberry now. Home K3S L4 TCP expose services and DNS. So he's using traffic ingress, so built-in ingress located. Yeah, this is not what we need. But yeah, exactly. We're gonna use this metal LB, yeah, this metal load balancer. But let's actually save that. That's a good research. That's a good research he's done. So let's save that. It's probably gonna need that as well. And then let's save this research as well. So we're gonna do like setting up Cloudflare DNS. MD, right? Oops. So we'll need to read that as well. Wow, they actually do provide, so this external DNS actually supports Cloudflare, which is not strange, but that's awesome. Nice. Creating a Cloudflare DNS zone. Ah, so nice. That's exactly what we need, right? So let me just smack this in there. That's very good. So yeah, so that's very good. So I will not need to write custom code and scripts and shell scripts and blah, blah, blah. So we can actually do this as part of K3S. So we can say somewhere in the manifest, eventually we'll be able to say, hey, when you deploy this thing, also set up this DNS automatically. That's super nice. Okay. Okay, very good, very good. Never mind, I thought this was a markdown file. Okay, great. Let's see, there actually became super quiet here. I guess it's because not many people can. Is there anyone still around, or did I put everyone to sleep? How long have I been streaming? Maybe we can round up. Ah, people are here. Okay. All right. Around. Okay, got it. Okay, so still there. Okay, good. I will stream tonight again. I will stream. Yeah, I will definitely. Yeah, I'm back to streaming. I'm definitely back to streaming. No question about that. So I will stream 99% tonight again. So if you guys are around, do it, because I haven't eaten yet and it's 2 p.m. So I need to have my breakfast and I need to go to gym and stuff. I need to go running. I need to spend some time with my kid and wife. But definitely I'll be streaming for sure. I'll be streaming again. I'm back. And we continue with this. It's going to be a little bit complicated for many to... What time will you stream? Probably around 9 p.m. Not sooner. I'm gonna spend the day with my wife and kid, and need to go build some muscles. Have a leg day in the gym today. Gonna do maybe 5 or 10 kilometers of running, and then I'll be ready to continue tonight. I will, in the meanwhile, probably summarize what we did so far in the stream and push and commit it to that repo so we can kind of easier follow up. Man forgot to bake rumpir. Exactly. So that's what we're gonna do, guys. It's been pleasure to it's pleasure to be back. Especially pleasure to see all of my crew here, Rebecca and Leo and Cedric and Chica and everybody. It's so cool to have you guys around. In fact, it's quite crazy that you guys are around. So it seems that you kind of liked my stream and liked me. So I have no other explanation. So it's a pleasure to have you guys. You're the reason that I keep coming back. So thank you very much for being around. And yeah, if you guys are around tonight and you're bored and inflate your ego as much as possible. Exactly, absolutely. Need to keep myself afloat, right? So yeah, that's how it is. All right, guys. We like you, man. Well, thank you very much, guys. I like you too as well. That's very inspirational. I wish you guys a great day, great weekend, and yeah, if you have time tonight again, come around and let's have some fun and learn something together. Craft, also a pleasure having you, and I'll see you guys tonight. Okay? Have a great one. Bye-bye.